Switch track. Transfer track. Switch track.
For the blue bar. Thank you for riding Icebreaker and enjoy the rest of your day here at SeaWorld.
Transfer track. Let's talk about some of the ins and outs of track switch operation.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Alright, today's episode, we are going to be talking about switch tracks and transfer tracks. So, what is a switch track? Well, it's a piece of track that can be moved into and out of position. Well, it could also be raised and lowered into position or moved someplace from one place to the other in position. So, that brings up the question, what's a transfer track? Well, transfer track is something that generally holds the train while it's moved from one place to another. So a switch track is a piece of track that moves between two track segments. So you'll have a switch track connecting track number 1 to track number 2, but also track number 2 to track number 3. So the train will, let's say, come in track 1, go over the switch track, into track 2. While it's in track 2, the switch track will move, and then the train will then proceed from the track number 2 to track number 3 once it crosses back over the switch track. Transfer tracks, on the other hand, don't really make the connection between three pieces of track. They typically substitute the connection between one series of track and another. For instance, on a transfer track, if you stop the track out of position, it would neither complete the circuit in track number 1 nor track number 2, and it is holding the train at that point. So if you just stop it anywhere, it's holding the train. You don't have to worry about it. A switch track, on the other hand, if you move it out of position, there is a train moving in either direction typically that you have to guard against. So transfer tracks are a little more on the safer side compared to switch tracks. One of the reasons why switch tracks typically, up until recently, weren't really used a lot in rides because they were very complex and very dangerous essentially in the track setup. When it comes to transfer tracks, they generally move much slower because they hold the train. So switch tracks can move really fast. Transfer tracks, typically moving the train, move on the slower end of things. Now, some of these tracks out there can move quickly as well, but generally when you're holding a vehicle and moving it at the same time, the track has to move slower. It needs more time to move from point A to point B, depending on the size of the vehicle, of course. If you're doing something like moving a Mad Mouse type coach, a lot of Mad Mouse rides, they don't even really have a transfer track that's automatic. It's simply just people pushing it from one side to the other. I know we had a track where we did that ourselves. Fun fact, most B&M roller coasters don't hold the transfer track captive in any way, shape, or form. So it's kind of weird to think about it. If you were to look at the front of the transfer track just as it's moving along, the transfer track would essentially... the transfer track doesn't really have like a set of upstops. It's got some guides, it's got road wheels, but it doesn't have upstops. So theoretically, the entire track piece plus the train on top of it could fall over. It'd be really hard to do, but theoretically it could fall over. So that's kind of a weird thing to think about. Yeah, there's nothing guarding it in that direction. It could just go on the side and fall over. So recently in the industry, a lot of manufacturers have been installing track switches and transfer tracks in the rides, not because they needed to, is because it's become its own element, its own something to do. There's been lots of rides out there where they could have just changed the direction or done something else to keep the vehicle moving, but they decided to use a track switch or a transfer track in some sort to bring the train in and change its direction or change its track that it's going to. So why do we love switch tracks in general? I like switch tracks, but why does everyone else love switch tracks? Why is this a thing that we all love to see? We all want one. We all want that thing. It's like, why is that? Well, fundamentally, deep down, most of us just want to ride something backwards. It's really fun to do. Going backwards on a train is really fun to do. I know, believe it's Mac out there has started putting seats on trains where they put the back seat on backwards. They built a special coach for a backwards coach on one of their trains. Several manufacturers have done some fun little things like that. But a lot of us want to ride a roller coaster backwards. Now, what does a track switch mean? It means 9 times out of 10, you are in fact going to be going backwards. It's a really fun thing to do. We all like to go backwards, especially get some speed. I have not ridden it yet, but can't wait to go eventually on Top Thrill 2 and get that rear spike going backwards, all that speed. That's fun. The first time I went backwards on a fast roller coaster was a Skyrocket 2. Got that reverse launch out of the station up the back tower. That was really fun, so I can't wait to do that at a faster rate of speed. So along those lines, generally track switch are used to change direction of the train. You were going forwards, now you're going to be going backwards. So on a lot of rides, now this isn't the case for all of them. There are definitely rides that only do this one way, but on a lot of rides, you not only use a track switch, but you use 2 of them, because sometimes you will make a circuit, you will go forward through the track switch into circuit A, and then reverse in circuit B, and then you'll have to stop through another track switch and go forward into circuit C. Now, rides like that I can think of right off the top of my head, Expedition Everest at Disney's Animal Kingdom, right? You go up, stop, the track switch rolls over, you come backwards, you go through the inside of the mountain, you come up through another track switch, stop, it rolls back over again, then you go forward again. Now, there's another ride out there, I can't even pronounce its name, so I'm not going to, but it is the other half of the rides. What these do is they go forward through a track switch, they go up a top hat type of element, and then at the top of that, they don't quite make it over, so they roll backwards. And the track switch is necessary to allow that train to go backwards and get reversed power, get some more power up a rear spike typically, and then go forwards again. So you've developed an intermediate ride swing style launch where you go swing 1, swing 2, and then swing 3, go back up and over. So about a good chunk of rides are built like that, where it's giving you a swing style launch over a top hat or there's some other type of element. And the other half are kind of that we're going to go forwards, backwards, forwards again to complete that extra part of the thrill there. So when it comes down to the function of switch tracks and transfer tracks, the speed is kind of dependent on the function and what it's doing. Like I was talking about earlier, on a switch track, the switch tracks generally move really fast. They can move really fast because they have nothing on top of them. Switch tracks are generally sliding left to right or slightly rotating 20, 30, 40 degrees to one side or the other. So the only thing they have to account for is the weight of the track itself on top of that uniform table. Now, the other type, a transfer track, whether it be sliding left to right, I mean, some transfer tracks go up and down for service bays. I think it was the big one. The track goes up and down to let vehicles in and out of like maintenance areas. And rotisseries, like Voltron has a rotisserie. So that is, in my mind, that is not a switch track. That is a transfer track because, again, you're holding the train captive while you are moving it. So again, my definition, and now this isn't an industry term thing. This isn't like, oh, the whole industry does this, the whole industry does that. These are very close to, or in a lot of cases, they are ride elements. So the manufacturer is going to call it something. They're going to talk about it one way. The park is going to put their own spin on it. So everything is different almost across the board. Typically, the only time they really kind of even come close to standardization is when you're talking about maintenance functions, putting trains away. Like Disney's California Adventure, the Incredicoaster, used to be California Screamin'. They have a series of track switch in front of their maintenance bays. So when they need to put a train away, they line the track switches up and move the train away real quick, and then the track switches go back to normal operation. Now, on a lot of rides, a lot of B&Ms and a lot of stuff like that, they use transfer tables where you put the whole train on top of the table and then move the whole thing over. And they typically move really slow because they've got a little motor doing a little tiny bit of work. They don't need to go crazy fast because most of the time they want the ride in a non-automatic mode while they transfer stuff. So basically that all goes back to the more weight you have on top of it, the slower it's going to go in general. Like I said, it's not going to hit 100% every single time. In general, big train, slow track. It's what you're going to have. Nothing on top of the track, it can move pretty fast. Now, switch tracks and transfer tracks operate in a defined area, which means that they are on tracks themselves. So the switch track is on a track. The transfer track is on a track. In the case of a rotisserie, it's pretty much mounted hard to a bearing at the bottom, so it's not going to go anywhere. What does this mean? This means that its path is predictable and defined. We know exactly where it is going to go, and we can move everything within a very small, tight area, very precise. So typically, when the track switches are fabricated, when the area is built, I should say, that the track switch or transfer table sits on top of, it is built to a very precise measurement. The tracks have to be level within a couple of seconds of degrees. The measurements have to be spot on in all directions because you're going to bring track up to it. Typically, the track is also anchored in such a way that prevents expansion and contraction joints. Now, this is an interesting thing by itself. Tracks expand and contract with the weather, with temperature, with heat, with cold. What does that mean? Well, that means on older rides where they didn't have quite very good control of things, that means the gap that would sit there where the transfer track or a switch track or something would have to sit on, that gap was variable. During the daytime when it was really hot, it might be, pick one way, it might be really wide, or in the other direction, it might be really narrow. On our wooden roller coaster, wood is a living, breathing object, right? So on our wooden roller coaster, when it got really hot outside, a lot of times we couldn't move the transfer table because the track had swelled up and had literally pinched the transfer table on both sides. And the thing could not move. It was literally wedged in there. So the design of track now is very important to make sure that when they anchor the track on both sides, they do it in such a way where it's not going to go forward or backwards. Now, an interesting thing to do this, you think, well, it's mounted in the concrete. How would it move? Like, all that stuff has deflection. Anytime you make something vertical, it could still deflect one way or the other. So what they do is, instead of doing this number where it's a pole holding the track, they took the track here, they put the pole underneath it, and then typically underneath that, a lot of times you'll see a 45-degree angle piece of metal coming down, another support coming down to 45-degree angle. That angled pole right there is the one that actually anchors it and keeps that track from going forward or backwards and actually holds that steady. Now, sometimes you might not see that. It might not be there because that function is actually buried in the concrete down below. It's like it'll look like a U like this, where the track is mounted on both sides and you have physical metal holding it in one shape. But it's not just a loose pillar and a loose pillar. Construction standards have gotten a lot better too, so not all of it's quite that necessary anymore, but some manufacturers still like to make sure that stuff is dead on accurate. All right, so let's talk about movement of the track switch or the transfer track. Talk about both of them. All right, so in a lot of cases, track switches are pneumatically powered. Now, by pneumatically powered, I mean they have a pneumatic ram pushing them from one side to the other. All right, so pneumatic ram, one of these guys, when you apply air pressure to one side, the ram extends out. When you apply air pressure to the other side, the ram retracts back in. Now, that's really all it needs. The size of the ram is going to be defined by how much the track has to move on either side. that is what's called the stroke. The stroke of the ram is how far it moves. So if you have a transfer track or a switch track that needs to move this defined area of, let's just say, 4 meters, then you need a pneumatic cylinder that goes 4 meters. Now, one of the problems with that is that the longer the cylinder has to extend and the longer it has to retract, the more time it needs to do that. So you can build a cylinder just like this. In fact, I can call up a cylinder manufacturer that builds these things all day long and just say, hey, I need this exact size cylinder, but I need it 4 meters long. I'll be like, yeah, sure, no problem. We'll build that for you real quick. They go out, they cut this tube, they put this stuff on, they build the cylinder that goes, they build the little piston that goes inside, and they ship it to me. I'm like, that's great. When you extend this cylinder all the way out, all the pressure is riding right on the end of this guy right here. So this makes it kind of get loose up and down like this. When that happens, that means that you start wearing out all the bushings and the seals on the inside, and they start leaking like crazy. So it's in your best interest to keep these throws for those transfer tracks as short as possible. That means when you look at things like switch tracks in general, you'll see that they're very, very tightly built. There's no room side to side. In fact, if you looked at the Incredicoaster switch track, a lot of Intamin switch tracks, you'll see that the distance between them is only about 400 millimeters. Why around 400 millimeters? Because their guide wheels are roughly 360 millimeters. So that means as the guide wheel passes through on the side of the track, that there's only about this much space between the side of the track and the side of the wheel and the track next to it. So it's a very tight area, but they want to keep that throw on that cylinder as short as possible. Now, there's a newer technology out there. I shouldn't say it's a new technology. It's an old technology, but it's a newer thing. Typically on switch tracks, we use pneumatics. You push it from one side to the other, and it goes up against a hard stop on both sides, meaning the cylinder and the track max out at the same time, go, and it maxed out. It stopped. The piston ran into the inside right here. Now, at the same time it does that, or just before that actually, the track will hit a mechanical stop at the bottom as well. So once it moves all the way over, the piston will actually start putting mechanical pressure up against the entire assembly, forcing that track to one side. Now, what they've done recently is actually started using belt drive systems. Instead of using an extended cylinder, they've taken essentially a drive belt or a cog belt, and they've wrapped it around one side and wrapped it around some pulleys and brought it all the way back to a servo drive motor. Servo drive, stepper drive type motors, they are extremely high torque, they can move really fast, and they're extremely accurate. So they can take those systems, turn it on, and then move the track over to one side really, really fast and give it the appropriate ramps it needs. That motor will spin up really fast, and as soon as it gets close, it will slow back down and stop. What is the advantage of that? Well, with the pneumatic cylinders, you're literally ramming the thing into position on one side. You're literally waiting for it to go clunk and stop. Now, once it stops, it extends a locking pin, which is basically in the direction of travel. It is another cylinder that extends out and locks into a bore. It locks the transfer switch or the track switch into the roller coaster track on both sides typically. This is visible like when the track is over, you can see a hole in the end of the track. That's got a cylinder behind it with a big, basically a rod that sticks through both holes at the same time and keeps it locked into place, so if the cylinder moving it were to go haywire and just decided to change position, it couldn't. Both of those are pneumatically pinned into place. So on that servo drive where I was talking about using the belts to move it into position, you don't have to force the track into that position. You can move it right over within probably a half millimeter and just stop it right there. So you move the track over, it doesn't actually need the stops on both sides. You simply just tell the servo drives, or the stepper motors basically, to move the track over and stop it in that exact position. And then use a series of proximity sensors. Use a flag plate, it's about this wide, with a proximity sensor on both ends, so that it knows that it's within just about a 1 or 2 millimeter window. So when the drive says, okay, I'm in position, you should have probably 4 proximity sensors that say, yes, we're in position on both sides. And then both the rams extend. At the end of the ram, there's another proximity sensor that will measure the end of the ram and says, yep, the ram is locked in both sides. So now I have the ram is locked both sides, and I have 4 proximity sensors that say it's good. It's locked into the position it's supposed to be into. And then a lot of times you take, if there's air pressure to the moving ram, you would actually take that pressure away to make sure that the track doesn't move unintended. Now, while it's in that position, you may see on some tracks that it looks kind of like a brass bar that's sitting on the end. So those sit to take up the gap between the switch track or transfer track and the ride track on both sides. That gap is critical because they don't want that transfer track or switch track walking during that time. By walking, I mean moving side to side and wobbling around as the train goes over it, because that basically creates impact. Every time it impacts, it creates a little bit of stress, and then you could wear things down. You can do things like crack cylinders, you can crack the track and all sorts of stuff like that. So the manufacturer likes to keep the weldments and the precision on those as tight as possible and as clean as possible to make sure that the system doesn't wear down. It won't cause immediate headaches, but down the road it'll start causing a lot of headaches once it gets a handful of years of service life underneath its belt. So then you've probably been at rides and you've seen some of these track switches or transfer tables being used, and you probably don't see some of the stuff I'm talking about. It looks kind of just like a clumsy piece of track that just kind of flops over into position. Maybe it's got a cylinder holding it on one side and nothing else really. It doesn't look like much of anything. Well, speed plays a factor in how the track switch or transfer track is constructed. By speed, I mean how fast is the vehicle going to be going over it. A lot of times at amusement parks, we see track switches being operated just coming into or going out of a station. A lot of places use that. It's a switch that comes into, so as you're going into the station, you can go into side A or side B, station 1, station 2, whatever you want to call it. So those switches that are being used just in front of and behind the station are low speed switches. They don't require much engineering to them because the train is only moving at a walking pace over the top. So it's got brakes in front of and behind it. It's very well guarded. People can see it easily. There's not a lot they have to do. So the construction standards on those are typically a little bit lower than somewhere else. The more precise ones you see are ones that we like to see out on the track, which is a mid-course track switch. Mid-course track switch where the train runs over it. These are the ones where the train will rip over that thing going 40, 50 miles per hour, and then the track switch has to move over quickly while the train is out of position. Manufacturers keep speeding up the speed of these track switches to move faster and faster by getting rid of pneumatic drives and replacing them with electronic drives and things like that. The track switches can move really fast now into and out of position, but that means the tolerance has to be tighter, the movements have to be tighter, everything's got to work tighter, especially when you run the train over it faster. The train will tear things up more if it has room to wiggle the track around it all. So all your precision in all directions have to be tighter. Okay, so let's take a look at this video. This is by Front Seat POVs. One of the big questions I always get is, how do they prevent these from going backwards over the switch track when the track is out of position? So one of the big things to note is that on a lot of these things, people don't see the mechanical brakes. So they're like, if that thing's out of position, everyone's going to get messed up. But let's point out a bunch of stuff on these videos and let's talk about this one particular ride, which is very common. It's out there, it's seen everywhere. So let's use it as an example. Here we go. All right, right here, right off the bat. Coming out of the station, we're coming down a little pre-drop here into this area. This is an acceleration run. So this is, let's see what is going on here. We're going into stators. There we go. Pause it right there. All right, right here, right there, whoops, right there is more mechanical brakes. These are brake fins that are retracted back down into the track. Now, on linear synchronous style rides, those stators, when they're not being powered, they're grounded to a braking resistor. So when the train comes back over these, they naturally act as brakes during the entire time. So essentially, even though it's being accelerated, when you take power away, e-stop condition, anything like that, this whole assembly turns into a giant brake run. So that's important to know. So we're going to call this is the start of block 1. Okay, we're going up and over these elements. Now, right here, this is the highest part. So this is, we're going to say this is like a naturally reoccurring, this is like a natural block element, like it's a divider. So if the train didn't accelerate enough coming out of its initial launch, then it would make it to this point and it would roll backwards. And those stators would act as the brake, it would catch it, so that's a natural divider. So moving along from here, we're going to go along, and then coming out through here, we're going to do some S-bends, stuff like that. Now we're getting to the switch track area. Here's the switch track right here. Okay, we just passed over the switch track. Now what do we see? More stators. Very cool. Okay, what do we see here? Right here, those are more brakes. This little hill, what do we see here? More stators. Okay. Up and over the top hat? Nope, we're going to fall short. Now, during this time, as soon as we crossed over that track switch started to move out of position, which was okay because the ride already knew the train had passed all the way over it. It said, go ahead and move the track switch. The track switch is out of position, and as the train is coming backwards, all those stators that are behind the train that we just went over, every single one of those stators is in braking mode right now. And if there was a problem, those extra brake fins would come up and out of the track. Now, where would that stop? You would slow down right here, and then you would basically stop right here. Now, when the manufacturer, I'm pretty sure this is an Intamin. Square stator drives, yeah, pretty sure this is Intamin. When the manufacturer tests these rides, they've already done all the testing. They did full weight testing. They sent that thing up and over, and then as soon as it got up towards the top of that top hat, they hit the e-stop. And when it came back down, they made sure that it stopped. Honestly, it probably stopped before it even got to these mechanical brakes right here. It probably stopped in the forward part of the ride. But because there's a lot of stairways right here, a lot of access panels, this section right here is where it's designed to stop. So it's probably designed to do a slow crawl just right back down. When I say crawl, not under power, just means it's trying to scrub off its last little bit of speed as it's slowly coming back down into this natural valley right here. Forward the video a little bit. Into this valley where it's going to rest and stay when the ride is faulted. Going back over it, here's the track switch right here. It's out of position. It's monitored. We said, okay, before we even got up that top hat, this thing was already locked into this position, and the ride knew that it moved over far enough, and the pins locked itself into place, and it was good to go. As soon as those pins verified locked into place, the drive went into its next profile for reverse. We passed back over it here. Now the drive is already in profile. This would be, let's see, that would be one. This would be, let's see, one was freehand. So this would be profile 1 in reverse. This would be profile 2, I'm guessing, coming back forward. So we're going to come back forward. Drive's in profile 2. Now, we've passed over that track switch just now. Gonna go forward, drives accelerating, accelerating. All right, right here at the top, this is natural block border again. Now, this is the highest point on the ride, so the manufacturer assumes if the entire train makes it over this hill, that there is nothing on the other side of the ride that can get it to go backwards again. So this is a natural block boundary. So as long as it goes over this top hat, we are going to say it is safe to reset that track switch on the other side. Going down, and probably right about here, there's a proximity sensor down there that the train passed by, and as soon as a train passes by that proximity sensor, that track switch goes, okay, click, unlock the track switch, move it back over, and then as soon as it's locked into the first position again, the next train can dispatch. That's part of the block system. All right, this next video we're going to look at is by, it looks like Roller Coaster. Not sure if I'm saying that channel name right or not. But anyways, this is the off ride of the exact same ride. So we're going to watch this real quick, and we're going to look at the track switch from the off ride position to see it switch into place. In the rain, man. Okay, so here it comes into the track switch. There it goes. As soon as it crosses over, it's moved into place and locked in, which is really cool. I mean, the track moves nice and fast. Waiting for the train, comes back, comes over, it's gone, locks back, into place, ready to go. Crosses, moves over, locks back. Now if you look over on the right hand side down here, you can see the gear move. You look down over here when it moves back, not from that angle, I'm sorry. Right here, look down over here. See that gear down there? You can see that gear move down there as it's winding back and forth. This is either the cog belt or drive chain, one of the two. Here it comes back up and over. There it goes up that back spike. Great looking ride. Absolutely amazing. Comes back over. Now it's got to go up and over that top hat, remember? And then as soon as it crowns over that top hat, the system says, okay, go back, and right there, that train is ready from the station to launch again. So it's going up the top hat, it's rolling backwards, the brakes are down because the transfer track is locked into place. It's going back up again, it's going to come back down. Again, transfer track. It's waiting for the block reset on the other side. So it's going to come back down. This is what profile 2, I think it was. It's going to go up and over, and it's going to reset right there. It resets and says, okay, I'm over far enough. Go ahead. I wonder if we can see it here. No, we can't. Basically, if I pause the video right there, the train has passed the 50-50 point on top of the ride, up on top. So once the train passes that 50-50 point, it says, okay, everything has passed by. The train can't roll backwards again. So once a proximity sensor, there's either a sensor down here that just says, okay, train's over, go ahead and release it, or the proximity sensor is up on the top up here, and it's counting as it goes by. It's watching the coaches. It's going, I believe, let's see, we got 1, 2, 3, 4, I think the 5th coach up there. So as soon as it counts 5, 1, 2, 3, 4, 5, then the system gives the reset signal and causes it to move the track back over. We see it here. Somewhere up there, not sure where exactly. But you can see some of the rails there for proximity sensors and things. and some of the wires and cables up there. So somewhere right in this area at the very top, it's probably counting the train as it goes by. 1, 2, 3, 4, 5, and then the track switch says go ahead, reset back to your other position. And it resets right there. And then the track switch says, okay, back to position 2. Some of the most aggressive elements out there on rides are actually transfer tracks of all things. Well, I could think of 2 types of aggressive transfer tracks out there right off the top of my head. Can you think of any? Well, right off the top of my head, I could think of a drop track, right? Thrilling? Absolutely. Especially if you don't know it's there, right? Well, a drop track is essentially a transfer track. The train is loaded onto it. It is locked into position. The track moves. In this case, it's a drop. And then the train is offloaded. The track is reset to another position. So because the train is carried on the track, in my definition, that's a transfer track. Now, can you think of another example of an aggressive transfer track? I can. Let's look at a tilt track, right? A tilt track is a transfer track. It is loaded from track number 1 to continue on. Well, it's just a continuation of track number 1, but we'll call it track number 2. So the train is loaded onto the tilt track element, locked into place. The track moves into a different position, and it's unlocked. The train goes down. Now, that is a transfer track as well. Both the drop track and the tilt track are both just transfer tracks. Now, they're weird. They move out of positions, but yeah, they're both just transfer tracks. So what's next in the world? Well, looking forward, it's like we've already taken transfer tracks. We've moved them left to right. We've moved them up to down. And then we've taken switch tracks and we've moved them left to right. And we've also built other types of transfer tracks that have tilted and dropped. So where do we go from here? Well, I've seen companies out there. I honestly looked for this and I could not find where it was. Doesn't mean I won't find it right after I make this video because I always do this sort of stuff. But there are companies out there that have developed, I want to say it was dynamic attraction. I might be wrong on that though. They've developed robotic switch tracks. What's robotic mean? Well, you know how a lot of companies right now are using those KUKA arms to basically move people around and do all sorts of stuff. They basically did the same exact thing. They built a giant robotic arm and put the track on top of it. So you could go in to this would be a transfer track in this case. You go into a transfer track and stop, and then the arm could take you, rotate, turn you backwards, turn you upside down, do whatever you wanted to, and then let the train go again in a different position. So robotic transfer tracks, I think, is where we're going to. This would be stuff that would probably pop up first in dark ride scenarios. I know there's a couple rides out there that use similar types of tracks where they slide out of position into the next one. Some drop, some slide. So now there's basically, okay, you're going to load the train onto, basically it's a KUKA arm, and it's going to move the train around. It could even be on another track, you know, it could take you down a whole nother track on an arm and then connect you to a different track somewhere else. That would be really interesting. Can't wait to see where that type of stuff is used, but should be interesting. Now, when it comes to the general safety of these things, I went over a lot of these points already, but we'll talk about it one more time. We're going to monitor the track into and out of position, which means that we're going to monitor both sides, the running and non-running side. And when we're going to lock the track into one side, we're going to make sure that at least 2 or 3 devices have positive feedback stating that the track is actually there in front. We can use proximity sensors at both ends. We could use proximity sensors with optical sensors, making sure the track is in the right position. We could use laser feedback systems. We could do all sorts of stuff with this. We could use those systems, and then on the other side, the side that's not locked, we're also going to use proximity sensors and things on those sides, stating that the track is in fact not there. A lot of rides do that, right? When we do A/B comparison checks, we want to make sure the sensors on this side went high, meaning that they were flagged, and we go yes, and then what do? We just say that's all we care about? No, we look backwards and we say, hey, the sensors over there that are supposed to be low, they're low, right? And they go, yeah, they are. So a lot of times when something happens on a ride and it stops and produces a fault, that's because out of 4 sensors monitoring it, 2 went low, 2 went high, and when it did its check, one of them on the other side was still low, or the 2 sensors that were on the high side, one of those dropped out. So you had 2 low and then 2 that were supposed to be high, but only 1 was high. And then that caused a comparison fault. It's like, hey, I want to say this thing is supposed to be on this side, but all my sensors can't confirm that. I've got the majority of them that said yes, but there's one that's giving conflicting information. Now, in the amusement industry, what do? We stop. We always stop. Anytime there's a conflict of information, we stop. That is the safest thing to do, is we stop everything. That's the end of it. So we stop it, and you get to sit there for a little bit until somebody comes out and verifies things are in the right position, resets the ride and gets it going again. Or if the ride doesn't reset, that means the sensor is probably broken, and that's when you get to get off the ride and do a in-show exit or a walk-off or an evacuation, whatever it might be at the time. All right, I think that's about it for this video. I think we'll transfer to another topic. If you want to, go ahead and comment downstairs, like, subscribe, share. Watching the videos really helps me out. I do appreciate that. And if you want to see more of me, just keep watching the videos. It gets in your algorithm, and it suggests me more and more. If you really want to, hit that bell icon and get notified when I release the videos. I try to release videos. Right now I'm doing every Monday at 10 a.m. Central Standard Time. If you want to, you can always email me at ryantheridemechanic@yahoo.com. And as always, stay off the air gates.